Welcome to this presentation of what's new in Answer and Meta for CFD in version 25.1. With Beta CAE joining the Cadence family, we're now able to provide our users with more solutions and more complete processes. Let's start first of all with the new Fidelity CFD solver, the pressure-based solver for CFD with differentiating technology. It has a coupled solver that produces fast steady-state convergence, a segregated solver for fast transient simulations, a novel linear solver technology that provides stability and robustness. It is an all-speed solver for incompressible, variable density, compressible and supersonic flows, all in one formulation, and it is specialized for automotive applications. It has been written from the beginning to be supported on both CPU and GPU hardware, resulting in very fast solution convergence. It supports incompressible and compressible flow, steady-state and transient simulations, multiple reference frames, porous media, nonconformal interfaces, rotating domains, and various turbulence models. A big benefit is that both Answer and Meta are tightly integrated with Fidelity CFD and also with Fidelity AutoSeal. This means that our users can now have the complete solution, from CAD input to results reporting. We start with Answer, where we can input and organize our model, then use Fidelity AutoSeal, now fully integrated inside the Answer environment, then create a high-quality Hexstream volume mesh and set up the full CFD case for Fidelity CFD, all inside the Answer environment. The output case is then run in Fidelity CFD, providing high-quality results in a very short time. The results are of course post-processed by Meta, which can read its native results and create in batch mode all the post-processing actions and final report. So now Answer version 25.1 starts with Fidelity CFD as the default CFD deck. The CFD meshing profile function, which is accessible through settings, also has the corresponding options for Fidelity CFD. Other improvements in Answer 25.1 include the support of native AutoCAD DXF files and some improvements in the function isolate connectivity groups, where the function now retains the original PID name and adds a suffix per connectivity group. Moving on to geometry, we have brought back the function faces new, under the geometry ribbon, design group, so that the user is allowed to create a face in the old way, where they can specify explicitly its type, whether it is cones, fitted, planar, or using an existing surface. Moving on to surface meshing, under macros perimeter spacing, we have added a new biasing algorithm for hyperbolic spacing. In batch meshing, we have improved the speed and quality of anisotropic meshing, whether that's curvature anisotropy or anisotropy imposed by size rules. We have added a new function under surface mesh, watertight group, called convex wrap. It's a function that can be used to replace small detailed parts with a simplified convex wrap shape. This can be used prior to surface wrapping to reduce the detail and element count of the resulting mesh. A big improvement, of course, in Answer version 25.1 is the integration of Fidelity AutoSeal inside the Answer environment. The user can access AutoSeal from the watertight group of functions. They only need to specify the volume definition, whether they want to have the outer volume or an inner volume specified by a seed point. Then they can specify seed points, which are wet points, points where the flow and volume mesh should be present, and leak points, or so-called dry points, points where the flow and volume mesh should not enter. Then they need to specify the minimum leak length that they want to seal and limits on the memory usage and number of CPUs that are used. It's always advised that you set the maximum number of cores and a RAM that you have available in order to get the fastest and highest quality result. Upon specifying these few parameters, AutoSeal will automatically create high-quality patches to close all leaks. These patches are automatically assigned to the neighboring PIDs. The whole process runs in a few minutes to a couple of hours, even for the most complex geometries. There is also an option to create these AutoSeal patches, either pushing them to the seed points towards the outer surface, or the leak points towards the interior as shown here. As these new patches are assigned to the existing neighboring PIDs and parts, the user can still identify them through the Sets window, as Answer will put all these new patches in a set. The user can isolate the patches and inspect them from there. Moving on to volume meshing, we have made improvements in our Hexstream volume-to-surface meshing algorithm to reduce the memory consumption, especially for models with a large number of layers. So now we can reach speeds of just below 200 million cells per hour, with a memory consumption of always below 1 GB, even as low as half a gigabyte per million for low Reynolds meshes. Other improvements in Hexstream include the possibility to further reduce the cell count. We have added a new parameter to control the gap resolution. The low cell count setting will resolve a gap with the minimum number of elements, while the high detail option will perform additional refinement so as to better resolve the passage, but with increased cell count, as can be seen in these two images. Another improvement to reduce the cell count comes from the fact that now Answer can reduce the number of buffer zones, the number of zones of constant size hexes before the next octree subdivision, also on the surface mesh. This number can now be reduced even down to 0, resulting to a faster growth rate also on the surface. On the left we have 0 buffer zones, we have very fast transition, whereas on the right we have 3 buffer zones, which gives a smoother transition with more elements. Moving on to hexablock meshing, under Topology Group, the split function now provides a new option to split the boxes at an existing IJK index by selecting a perimeter node on the edges of the boxes. Another new tool is the new 2D box decomposition function. The user can select planar 2D faces and Answer will automatically create the topology of the 2D boxes. It will create a topology that can be map-meshed using Hexablock, and this mesh can then be smoothed using Smooth 2D to obtain a high-quality structured mesh. Our airfoil meshing tool has been improved so as to support C-type domains, and also it can automatically define the boundary condition so that the model is ready to be output, either in Fluent 2D or CGNS 2D format. Still in the Hexablock menu, the Turbo Template tool has been improved to provide better box topology and mesh quality. Let's move now to CFD Solver support. As we mentioned at the beginning, the Fidelity CFD Solver is our main CFD-supported solver now, so in the CFD ribbon under Solver Group there is a button called Fidelity PBS Setup, where the user can set up the full case for Fidelity CFD. First of all, they need to specify the general description of the flow problem, if it's incompressible, steady state, the energy equation, number of iterations and write intervals. Then in the second tab, they can specify the materials that will be used, then the fluid regions that are present in the model and the boundary conditions. So for every fluid region, for example, you can specify if it's an MRF zone or if it's a porous zone, and so on. And from boundary conditions, you can specify parameters like inlet velocity, etc. The initial conditions can be specified under this tab to initialize the flow field, either with potential flow or with constant values, and finally in the output requests the user can specify what they want to extract from the solver, like forces, coefficients, field monitors and so on. Then the user can press Setup Case and the case will be ready to run. The mesh and case setup can be output through File Output Fidelity PBS, or it can be launched from inside the Answer environment. The user can go to Fidelity PBS Run and solve the case locally, monitor the residuals and the progress of the solver. Answer supports the native quality criteria for Fidelity PBS so that we can ensure that we can generate a high-quality mesh that will run smoothly in the solver. Moving on to OpenFOAM, we support the Foundation version 9 and Raw Central Foam Solver. Some new tools to help the user to set up the model for the CFD analysis. A new function, Projected Area, for the quick calculation of the projected area of a model. Another tool that can be used to automatically calculate the effective radius of rotation of a wheel, taking into account the uncompressed and compressed radius, and if the user specifies the road velocity, Answer will automatically calculate the resulting rotational velocity that should be imposed on the wheel. Moving on to CHT volume meshing, we can now provide a streamlined process for the assignment of solid properties from the original solid component names that originate from CAD, either from the part or property name. So here in the model browser, we have input our CAD of this electronic assembly, and we can see that all the components are separated as parts. If we open the function Solids Naming in the Tools group, we can press Generate Seeds button and Answer will automatically take either the part or the property name and will create a 3D point inside every component, and this point will contain the information of the part and the property name. Then after volume meshing of the components, the function can apply the name information that it extracted from the part or the property back to the final volume property. By pressing Modify Volumes, Answer will assign the correct property to all the selected volume components. Moving on to our SPH solver, we now allow functionality for one-way coupling with CFD results. In this case, we have merged 3D CFD results on this SPH rain simulation, so you can see the effect of the water flowing on the hood of the car due to the external velocity of the vehicle. We also provide one-way coupling with FEA simulations. In this case, we can extract pressure results from the fluid on selected surfaces of the model and map them for FEA analysis. Additional improvements for the SPH solver include support of porous medium, export of compressed results from the SPH solver, restart simulations from previously saved results, new smoothing option to curves in sensor results, support of volume sensors, and support of multiple SPH simulation windows in the same session. For post-processing in Meta, we have improved our line integral convolution display on cut planes. It is now very fast and lightweight. The user can select from cut plane options, Results tab, Leak tab, activating projected type and control the resolution by the trace width. When reading native StarCCM results, we can read cut planes, flow paths, and ISO functions that were created inside StarCCM, and these will be displayed in the database browser of Meta so that can be easily visualized. Finally, we support the VTS ParaView format and the architecture keyword in foam file header of ESI Open Foam files in order to directly identify and load 32 or 64-bit format files. Thank you very much for watching.